Hello, this is Miss Moore, and today during chemistry, we're going to discuss density. Today's essential question: what is density and how is it measured? Okay, before you start today's lecture, make sure you have your calculators handy. We'll start with matter and mass. So chemistry is the study of matter, its properties, its composition, meaning what it's made out of, and the changes it undergoes. Matter is anything that has mass and volume. So now let's talk about mass. Mass is the amount of matter that an object contains. And we use weight to measure matter. So what is weight? Weight is a measure of the gravitational pull on matter. On to volume. Volume is the amount of space an object occupies. So how much space in the world, space in the world something takes up. Okay? Now the volume of a liquid can be measured using a graduated cylinder. And a graduated cylinder is really just a fancy scientific measuring cup. Okay? And if you're measuring the volume of a liquid using a graduated cylinder, aka measuring cup, your units, and we'll be talking more about units in a later lecture, but the units would be something about liters. Okay, L stands for liters. Okay, and it could be liters or milliliters or kiloliters, but it's usually liters or milliliters. And then we have the volume of a solid. So the volume of a solid can be determined in two different ways. First of all, you can measure its length, width, and height, multiply them together, right? So you get length times width times height, and that will give you the volume of a solid, and that would be for a regularly shaped solid like a square or something. And the units, when you're measuring this way, would be something cubed. So feet cubed or inches cubed, more often meters cubed, centimeters cubed, millimeters cubed, something like that. Okay. And you can also measure the volume of a solid by something called liquid displacement. So what you do is you take a solid and you add it to a graduated cylinder that already has a known volume of a liquid. And when you add that solid, you're going to obviously end up with, looks like more liquid, right? The height of the liquid will raise. So then you're going to subtract the original volume of the liquid alone from the volume of the liquid with the solid into it, and that will give you the volume of the solid. And often the units for this would be, again, in like milliliters or liters or something. Okay? So that's it for volume. Next up is density. Density, the whole point of the lecture. So density is a physical property, and it can be used to help identify a substance. So different substances have different densities. Okay, so styrofoam has a very different density than, let's say, a piece of wood or a block of marble or something like that. So the definition of density is it's the ratio of mass to volume, which is why we started talking about mass and volume. So in a more mathy looking way, density equals mass divided by volume, or D equals M over V, with M, little m standing for mass, and capital V standing for volume. All right, so that's the majority of the lecture. Now we're going to try calculating some density. All right, let's try a couple density practice problems. So we have a sample of aluminum metal that has a mass of 8.4 grams, and the volume is 3.1 centimeters squared. 3.1 centimeters cubed. Calculate the density of aluminum. Well, density equals mass over volume. So we have density equals the mass which is 8.40 grams, divided by the volume, which is 3.1 centimeters cubed. So now we'll just divide, and that'll give us, see, 2.7096777419. And then we now have the units grams per centimeters cubed. Okay, so the final step is to figure out our sig figs. So let's go back to our original measurements. We have a mass of 8.40. And so sig figs, well, the 0 here is significant, right? Because it's after a decimal and there's a non-zero digit in front of it. So our mass has 3 sig figs. And our volume here has 2 sig figs, which means our answer needs to have 2 sig figs. So we'll keep the 2 and the 7. And because the 0 is smaller than 5, we're just going to drop the rest. So our final answer is 2.7 grams per centimeters cubed. And these units here are important. Okay, let's try one more problem. So we have diamond has a density of 3.26 grams per milliliter. What is the mass of a diamond that has a volume of 0.35 milliliters? All right, so we're going to use the same equation, which is density equals mass over volume. But this time, we know density and volume, and we're trying to calculate mass. Okay, so we're going to have, we'll start with our density here. We have 3.26 grams per milliliter equals, we don't know the mass, so that'll be our x, over volume, right? 0.350 milliliters. All right, so the easiest way to solve this type of problem when you have two fractions with an equal sign in between is to cross multiply. So we'll end up here with x milliliters equals 3.26 grams times 0.350 milliliters, giving us x milliliters equals 1.141 grams milliliters. All right, so now, so what I did to get this number was to multiply these two, right? So now what we need to do is get the x by itself, this x. So I'm going to divide both sides by milliliters, leaving us with a mass of x equals 1.141 grams. And then once again, our last step is sig figs. So our density right here has 3 sig figs, and our volume also has 3 sig figs because the 0 is significant because it's after a decimal with a non-zero digit in front of it, which means our answer needs to have 3 sig figs, the 1, and the 4. The one that we're dropping is 5 or less than 5. So final answer is 1.14 grams. All right, that's it for today. Have a good one.